Hello guys, welcome back to my YouTube channel. My name is YAHMAD. So in this set of videos, we're going to be looking at computer science and we're going to be focusing on data representation. And in this first video of this series, we're going to be looking at denary and binary. So let's first start off with denary. So denary is also known as decimal. It's a number system which is base 10. So it's made up of any values from 0 to 9. And the example we have here is 157. So you can see each unit increases by the power of 10. So each number would be made up of the values from 0 to 9. Right, so let's have a look at binary. So binary is base 2 and is made up of only zeros or ones. So each value in a binary register is increased by the power of 2. So you can see we start off by 1, and then it goes to 2, and then 4, whoops, and then 8, basically doubling in value. So the first task that we have here is to convert binary to denary. So we have a 4-bit register, and we also have 8-bit registers as well. So we're only going to add when we see 1. So remember, binary is only represented by a 1 or a 0. So when we see a 1, we're going to be looking to add. So what we need to do, the technique is, for example, if this was your exam paper, you might only see this 1, 0, 1, 1. What I would do above the binary is to add the values. So 8, 4, 2, 1. So now what I'm going to do is we have a 1 underneath the 8. So I'm going to put here 8 plus, we're not going to add 4 because there's only a 0. We're going to move on to the next column. We have 1 again, so we're going to add 2. And we also have another 1, so we're going to add this 1 here as well. So 8 plus 2 plus 1 is equals 11. Okay, so this one is fairly straightforward. It's only going to be 2 plus 1. So 2 plus 1 is going to be equals 3. Here we have 8 plus 4 plus 2 plus 1, basically the maximum in a 4-bit. So what we can do is press 8 plus 4 plus 2 plus 1, and these things we can do in our heads, and the maximum is 15. So here we've done, we worked out we have converted the binary to denary for these 4-bit registers. Now we're going to be looking at these 8-bit registers, and now it gets a little bit more complicated. So what I'm going to do is add 1 to 8, since we have the 1 here, to the 64. Okay, and then if we move across, we see a 1 here for the 8. So plus 8 plus 4, and then plus the 1. Okay, so what you can do if you want to just use a calculator to save a bit of time. Obviously in exams, guys, you're going to be doing this in your heads, but let's just use a calculator for now. So 128 plus 64 plus 8 plus 4 plus 1 is equals 205. So just to remind you guys, we are only adding when we see a 1. In the exam, you won't get the values above, so I'm just trying to hide it. Well, in the exam, let me show you what you will see perhaps. Insert, yeah, let's get a shape like this. So you won't have these values above, okay? So it makes it really difficult to work out the binary. So my advice is to write the values above, then it's more easier to convert. So let's look at this one here. So we need to add 64 plus 16 plus 8. Let me just use the calculator again. So 64 plus 16 plus 8 is 88. So just to confirm, guys, we've converted these binary values to denary. Okay, so that's the easy part. Let's have a look at converting denary to binary. So we're basically doing the opposite now. So we have this number here, and we need to convert it into binary. So first of all, what we need to do is find out values which will add up to 7. Okay, so 8 is greater than 7. So what we need to do here is put a 0. I'm just going to increase the size of this. Okay, 4 goes into 7. So we can put a 1 here. 3 is left over. 2 goes into 3. So we can put 1 here. 1 is left over. 1 goes into 1. Job done. So 4 plus 2 is 6 plus 1 is equal to 7. Right, let's have a look at the next question. So we need to convert 14 into binary. So 8 goes into 14, so we can put 1 here. Let me just change the size again. Should have done this at the start. Okay, that will do. So 8 goes into 14. What's left? We've got 6 left. 4 goes into 6. And we have what's left over? 2. 2 goes into 2. And then we have nothing left over, 0. Okay. And the last 4-bit register we need to convert is this one here. So we need to convert 10 into binary. So 8 goes into 10. We've got 2 left. Just change the size again. 4 is greater than 2. So we have to put a 0 here. 2 goes into 2. We have nothing left and then 0. So we've converted these binary values into a 4-bit binary register. What we're going to do now is convert these binary values into an 8-bit register, so it gets a little bit more complicated. Okay, so just to help myself out, guys, I'm going to use a calculator, but in the exams, you would obviously have to work out these things for yourselves. Right, what we need to look at first is, does 128 go into 202? So we need to convert 202 to binary. And the answer is yes, but before we start, let me change the sizes of these into 36. Okay, so got my calculator ready. So 128 does go into 202, so we can put a 1 here. And what's left over? So what we're going to do is 202, take away 128 equals 74. Now does 64 go into 74? Was it 74? Yes, it does. And what's left over? We have 10. So 32 doesn't go into 10. We can put 0 here. 16 doesn't go into 10. We can put 0 here. 8 does go into 10. We can put a 1 here. And we only have 2 left. So 4 is going to be 0. We can put 1 for the 2. And we are now done. So we can put 0 at the end. And you can see the number is going to be even. So if the number is even, we don't need to put 1 here. If you did put 1 here, then that number would become odd. Okay, so let's do the next question. Okay, so convert 154 to binary. So again, we look at this first value here, 128. Does that go into 154? Yes, it does. 154 take away 128 equals 26. So it can put 1 here. 64 is greater than 26, so 0. 32 is greater than 26, 0. Okay. 16 goes into 26. Okay. And what's left over is 10. So 8 goes into 10. And we have 2 left over. 4 doesn't go into that. So we could put 0 here. 2 goes into 2. We could put 1 there and then 0 here as well. So what we've done here is we've converted some denary into binary. So this is a 4-bit register, the 8-bit register, and now it gets a little bit more complicated. We have a 12-bit register. Just before we do move on, guys, if we had all ones in the 8-bit register, the maximum it equals up to is 255. So let's have a look at this one here. So we have to convert this number here, 250, to binary in a 12-bit register. So I already know the maximum of this point is 255. So what I'm going to do is put zeros in the first 4 columns. And now let's look at this cell here. Okay, so 250 take away 128. So I know 128 does go into that. So 250 take away 128, and we have 122 left. So we could put 1 here. Okay, 122 left. So sorry, let me just do that again. Yeah, it was 122. So now what we're going to do is 122 take away 64. Okay, we got 58. Okay, 58 take away 32. We have 26. Okay, so 16 goes into that. Okay, and then we're left with 10. So 8 goes into 10, and then 0, and then 1 here for the 2, and then 0, and done. Right, the last question is we have to convert 351 to binary in a 12-bit register. So we are going to be using this bit here. So these 3 values are greater than 351, so we can just put 0, 0, 0. Okay, let me just get rid of this now. So 351 take away 256 is equals 95. So I can put a 1 here. Okay, 128 is greater than 95, so we have to put a 0 here. Okay, let me just. Now what we need to do is 64 is less than 95, so let's take away 64. So take away 64 equals 31. So I'm just going to put a 1 here. 32 is greater than 31, so we can put a 0 here. If I now take away this by 16, we have 15 left. So 31 take away 16. Okay, so what I'm going to do is put a 1 here, and we have 15 left. Okay, and then for the last 4 bits, if I have 1 here, I know this equals to 15. So here what we've done is we've converted basically 351 into a 12-bit binary value. Okay, so guys, I hope this video helps. I will be making some more computer science related video tutorials. Please drop your comments below and also subscribe to the channel again. Thank you for your time. Bye bye.